I'm Mike Lawless, and I just want to, I'm the host for this session. I just want to remind you to please submit your questions that you'd have for Eric in the questions panel. Click on the Q&A and submit your questions there. The speaker for this session is Dr. Eric Gemois of Simulations Plus. Eric is Director of Key Accounts and Strategic Alliances, and the title of his presentation is Collaborative R&D Models for Innovation. Take it away, Eric.
All right. Well, thank you, Michael, for this kind introduction. So yeah, I want to, share with you a few insights about, different ways in which we work with our clients. And as you know, there's many different ways that you can drive innovation. You can do internal development, you can do consortia, you can do lots of things that you can potentially do. And I think probably a good number of our customers assume that that we operate in a fairly monolithic mode of just simply licensing software technology, and although we do a lot of licensing works, there are other ways of working with our clients that are available to us. So we have actually a very diverse forms of engagements, different forms of collaborative works that we engage with our clients. And they're diverse in many different ways. There's many dimensions to the diversity. The value can be very different. In some instances, there's no cash involved. In some cases, there is. It can be, of course, we have many engagements in the pharma industry, but we also work in the agrochemical and the chemical industries. Um, the other thing is sometimes they're outbound. We are seeking a partner to accomplish something, but in other instances, it's the client who's coming to us and seeking for something, somewhat different from what everybody else is doing. Um, the the client may be a commercial company, but it can also be a government institution, as you will see later. That has happened in many instances. Can also be a nonprofit organization or an academic. Uh, the project may be focused on software development. It could be focused on something else. It could be focused towards discovery applications. So it can be at a different stage. Maybe it's something at discovery stage, but it can also be a project that is more into a later stage pharmaceutical development. So there's many different ways, different types of collaborations that we have. So and I these are examples that I've just taken from our press released events as a brief history of time, going from the most recent here to the less recent at the bottom. But as recently as about a month ago, we PR'd a collaboration about a lung exposure model for pulmonary infections that the partner was not disclosed. A little bit earlier in the same month, January 5, we collaborated around enhanced models for enhanced absorption of peptides that the partner was also undisclosed. Um, in October of last year, we collaborated around models for oral cavity route of administration that was with the FDA. Um, I mentioned that earlier in the HTPK session, but we've had two collaborations, one in April and one in September around HTPK, two different phases of collaborated R&D efforts with a large pharma company, which we did not disclose. And again, in this particular instance, what's very important is that we don't develop software in a vacuum. We develop software in interaction with a company who's representative of the space and to whom we know that technology is particularly relevant. So we make sure that we put the right capabilities, and especially important if it's something completely new. Um, and that was actually the case. We, as Michael just gave a very nice presentation about, AI-driven compound optimization. Back in September of last year, we had yet another press release around the validation of this AI based drug design um, technology, also with a large pharma. We did not disclose who it was, um, and you will see why. I mean, it's very important that we do this. Um, and if we go even a little bit further back, back a little bit over a year ago now, we also had a large pharma collaboration for quantitative systems pharmacology models for heart failure. Um, and then lastly, had a very significant, and we've had a very significant collaborations for many years with Bayer in Berlin. Most recently, working around expanding our capabilities for structure handling and polymer handling more specifically. So you see that there's again quite a bit of diversity of the type of engagements that we do. Some are not press released. Back in June of last year, for an agrochemical company, we provided some capabilities to do the same kind of model building that we do internally for site of metabolism models. It's just that these capabilities are not standard in Modeler, um, which is our the tool that we have for building models. So in this case, we enabled the company essentially with the same capabilities that we use, in-house to develop our side of metabolism models. And that gave them access to our proprietary atom-based descriptors. We also provided a lot of technical assistance with the implementation and also scientific support, because and actually Michael and other people with the company have a lot of experience in building site of metabolism models. And as with everything, it's just a lot easier when somebody has done it before you. um, so we spoke a little bit about the AIDD technology, and the fact that that was also done in collaboration with a big pharma. Again, this was press released in September of last year, and as you know, there's a huge amount of interest in that space, bearing different names. AI is often part of the name, but generative chemistry applications in general are getting a lot of visibility. And these are just a few examples of companies out there who have, technologies relating to AIDD. Um, some of them are actually our clients. So um, and as Michael elaborated a little bit earlier, this technology was actually released commercially again in September of last year. That was the AdMet Predictor 10 release, which contained this generative chemistry engine with some chemically intelligent transform. Everything is highly customizable. So if you can imagine a black box, this is just about the opposite of that. You can change just about everything. And it's coupled to the extremely fast multi-threaded property calculation capabilities that we have in AdMet Predictor now, which includes the mechanistic PK, which I described earlier in the HTPK module presentation. So as Michael described, it uses a Pareto-based selection process. It's just the mechanics that we use to select, one generation of compounds, the next generation of compounds from the previous one, and there are a lot of space where you can, customize all of these filters and so forth. And I don't need to go back into that, but there's some really higher level questions that I think everybody has when it comes to this particular kind of technology. Um, and the main one we had is that, how does this technology operate in a real pharma environment? Is it able to adapt to the specifics of a project? And that's sort of where the customization thing comes in. It has to be customizable to adapt to a particular kind of chemistry that you want to maintain, for example. Can it keep up with the requirements of the medchem team? Because medchem teams do have very specific idea of certain rules they don't want to infringe on, and so you have to be able to work with them in that respect. Um, and even sort of higher level, a little bit higher level than that, how does it change the dynamics of the interaction between the computational chemistry and the medicinal chemistry group? So that's kind of a big question. How much human input is required? Is this something you can just let run and it automatically does the right thing? And at the end of the day, I mean, the main thing we care about is, did we improve the compounds? Did we improve the compounds beyond what the MedChem team would have been able to think about by themselves? I mean, those are really, really important questions, and that's the kind of questions we want answers to kind of ahead of time, um, as we again further develop this technology and potentially add more functionality, to it. So other kinds of collaboration, again, drawing on this diversity that I mentioned earlier, as I said, the sort of switching gear here, the HTPK simulation was the result initially of an internal development, but then that caught on into a large pharma company who was very interested in getting access to early PK, essentially discovery stage PK assessment, because if you incorporate these kinds of considerations upstream in your designs, then you have a much easier time uh, dealing with, you have a lot less issues downstream, basically, when it comes to the pharmaceutical development of the compound. So, so again, this company was very interested, and so interested that there were actually two phases of these R&D cycles, providing, of course, early delivery of the technology to them, which again guided us towards what we ultimately implemented in the commercial release. So here are a few examples of these enhancements. Um, the main one had to do initially with enhancements to being able to specify arguments in the command line. Some had to do with the definition of C average, which is now AUC over dose. I think everybody pretty much AUC over the time period of the dosing period is what I mean. Um, Another one having to do with the output of multiple CP time curves, being able to overlay these curves, the way that David showed it in his demo, have multi-dosing, so being able to have one dose after the next, and so being able to visualize um, the steady state, essentially reaching steady state. Um, Various output options, extended output options for AUC, Cmax, Tmax, and then the second phase going into um, a new route of administration, IV bolus, and then the ability to define non-specific binding, the ability to define free target concentration, and also, as David actually showed, the ability to use either Ctrough or Cmax as in the dose optimization setting. So those are some of the flexibility that we can introduce in the software, um, and we're actually able to provide these enhancements to Admit Predictor users. The phase one developments, which occurred from January to June 2020, approximately, got delivered to the Admit Predictor community mid-September of last year, and then the second phase, um, which run basically from September of last year until the end of February of this year, um, that will most likely be released in the April-May timeframe of this year, so within the next few months or so. So again, there's a sort of a direct effect of these collaboration on what goes to our clients in terms of new features and enhancements to the technology. So I mentioned Bayer. This has been an extremely important collaboration for us that dates actually back a good number of years, but really initiated something that's very important to us, which is to have access to data for building better models. And that was certainly the case for the PK model. And as we alluded earlier, we have really the best PK model that's available out there, um, in silico model. And kind of what problem are we dealing with, there? And I mean, really, everybody or most people who are trying to build models for this particular endpoint are limited to the approximate 10,000 compounds mapping to about 14,000 PK values that are out there. And you're going to tell me, well, that's pretty good. That's already a pretty large data set. That's true. But the more you have, the better. And don't forget, there's a lot of diversity in chemistry. So you need to cover that um, uh, in multiple ways. So uh, and then on the other hand, there's pharma companies have extensive amounts of data, and then they're working in sometimes in new areas of chemistry space, which are very interesting, um, and they also do a large amount of data curation. Whereas typically, public data sources, we have to do a lot of curation, as Bob said. We see everything is tying up here, but as Bob mentioned, when we deal with public data, there's a lot of curation work that needs to be done. So working with data that's been um, in these hands before, it really helps a lot in terms of converging to good quality models fairly quickly. Um, so of course, there's yet another side to that coin, is that as data from pharmaceutical companies is highly confidential. So we need to guarantee, number one, the confidentiality of the data, that will not ever be disclosed, and also that there is no ability within the software to reverse engineer back to that data. And we do guarantee both. There is no way to do these things. Um, and and we also realize that in this particular setting, the bar is fairly high. I mean, especially, big pharmas have a lot of tools, either that they license or that they built in-house. And so the bar for us to provide a higher quality technology, even in terms of a PKA model, is quite high. And it's interesting that we were able to to succeed, and because it was, of course, set up as a win-win, and was such, and has been such for many years. So, um, so they really, through that process as well, got access to much enhanced PK models. Um, so again, in this particular setting, we were able to get close to another 20,000 multi-product ionization microconstants from Bayer alone. And if you add that to the 14,000 plus that came from public sources, then you got a total set of uh, 33,000 and change values, which is over twice what is available, twice the amount of data that is available from public sources. So you realize that with that much more data, we can build a much more accurate model than what would be just available commercially. So and what's also important is the implementation of it. It's just not the model itself. I think it has to be implemented in a way that conveys a lot of usability and a lot of information back to the users. And I must say that the implementation of our PK model is really superb. I mean, all the plots and the ionization plots and so forth are really, really nice in a predictor. Um, and the other thing is that PKA, ties to ionization, and ionization has so many repercussions on phys-chem properties all over the map. So you then realize how central that model really is for many other things that we do within the Admit Predictor platform. Um, so just, again, that gives you a sense of the diversity, but also the value of that, R&D innovation model in working in that way with our clients. Legitimate question is, well, how is it different from other forms of R&D collaborations? How is a focused, what we call a focused R&D collaboration? How is that different from a consortium? consortium during R&D. And it differs in a few ways. I think the timeline, since it is actually quite focused, the timeline is shorter, typically from 3 to 9 months, whereas consortia typically can run multi-year types of collaborations. The financial commitment is typically smaller than what would be, um, you know, requested through a consortium engagement. Um, the deliverables are contractual to that single client. I think that's probably the single most one of the most important aspects is that we guarantee that we will deliver these capabilities to the client, as opposed to a consortia, which I mean, even if something or you deem something is really important for you, well, you still have to hope that other members see it the same way and that they're going to vote the same way you vote. So it it again, it is somewhat different, and again, that's the one-one relationship that we have with the client in these developments, in the feedback that we get, but also, of course, in the feedback that they give us and what the next round of things that they want to see. So again, it's much more one-on-one as opposed to having fairly large consortium meetings. Again, it's a much more focused format of R&D, guided R&D development. Um, so I'm almost at the end of the presentation here. The last idea I'd like to share with you is sort of what are the areas now where we'd like to potentially collaborate with clients, um, and um, and there are a few. There's aspects that relate to the platform, and there are aspects that relate to the models, and of course data, because building models is a very, as you got from previously, it's a very data centric kind of activity. Um, on the platform side, we're very interested in building tautomer independent models. Um, and I think we have many people who see it that way as well. That they would like to see independence built in those models. Um, as Bob said, there's a lot of bandwidth that goes into data curation. It's very tedious. We found a few ways to make it a little bit more efficient, but I think I don't know if it will ever be feasible to fully automate something like that. Doesn't seem realistic to me, but at least there are ways to red flag outliers and things of that nature that is possible. So some form of semi-automated technologies that would relate to semi-automated forms of data curation are, I think, very interesting. And of course, AI technology is still very hot. Um, on the model development side, solubility is still an area where we think models can be improved. The same thing can be true of plasma protein binding, having new transporters. We released a new module back in September dedicated to transporters. I think it had 18 new models. Um, but it's, of course, it's an evolving area, so we need to keep up with um, not only literature, but also if we can find a client who has a specific interest in transporters, again, seek a an advantage through getting um, uh, larger amounts of data. So other areas would include microsomal stability, CYP inhibition or CYP induction, intestinal permeability, and data revolving around UGT metabolism. So that's kind of in a nutshell again, the diversity of the kind of engagements that we have, what has happened through these engagements, what they've resulted in terms of developments, and how significant these developments have been to our clients. And again, sort of the way of the future, where we think um, um, collaborative avenues might be. But again, this is kind of the outbound kind of perspective. There's also the inbound. I'm sure there will be instances where our clients will come to us with things we did not anticipate and say, well, we'd be really interested in pursuing this with you. Uh, of course, we'd be more than happy to listen to your request and work with you if that's something that is doable within Simulations Plus. So thank you for your time. Thank you for your attention, and I welcome your questions.